Hello and welcome. The topic of our discussion is ethers and its nomenclature. Hello and welcome. The topic of our discussion is ethers and its nomenclature. Ethers. The general formula for ethers is R, O, R. Notice that O has two lone pairs. Or it could be R, single bond O, single bond R prime, single bond R prime. So the structure on the left and structure on the right, they're almost identical. The difference is R. On one side you have R, and on second side you have R prime. So in this example, the R could be the same, so you might have the same group on the left side of oxygen and on the right side of oxygen, but also you might have absolutely different groups on each side of the oxygen. So the R is a placeholder for any alkyl carbon chain group or phenyl. Phenyl it's a benzene ring. Same goes with R prime. The only difference is the R prime could be different from R. So just like in this example, this is R and this is R if the group are the same, such as CH3 and CH3, but also it could be R, O, R prime if the groups are different. The ether group could be treated as the alkoxy substituent. So here is an example. Let's say we know that CH3 is methyl. Now, but if you have, for example, CH3O, then methyl becomes alkoxy. So let's say alkoxy. And we know it's methyl group because it's one carbon. That's why if it's only one carbon, we call it YL. I mean L, just like methyl. However, if it's OCH3, you refer to it as methoxy. Same goes with ethyl, for example. It could be ethyl if it's just two carbons, but it would be ethoxy if it's more than one. If it contains oxygen, such as OCH2, CH3. So this is ethoxy. And if you don't have oxygen, it's just ethyl. Here is an example. So in this kind of molecule, we got oxygen between carbons. So definitely note this is the ether. And on the left hand side, we got two carbon chain, and on the right hand side, we got just CH3. So there are two general ways of naming it. One method that we already named above. So here we go. It's we have to look for the parent chain. So the parent chain in this case it's F, having two carbons. That's why it's F for the parent chain. AN for single bonds. E means there are no other atoms except for carbon and hydrogen. So that's why we call parent chain ethane. But this is, we understand this is the ether functional group. It's meth because it's one carbon, and we only add methoxy part of it. We're not going to put any numbers because there are only two carbons, so you could technically put this OCH3 on this carbon or that carbon. That shouldn't make any difference. Another way to name this molecule is to go by just name two alkyl groups to the left and to the right of oxygen, and you would have to just do it alphabetically. So we know that this is two carbons, so it's ethyl. On the right side, it's only one carbon, which is methyl. So the way to name it, it's ethyl, because it's alphabetically first, then it's methyl, and then you just add ether as a ending to the structure. Ether structural view. So the general formula for ether is something we discussed. It's ROR or ROR prime. Now you can see it's a very similar structure to water. The only difference is instead of having two hydrogens on both sides, you actually have alkyl group, carbon chain on the left and carbon chain on the right. Here's an example again. We have for this molecule called, first of all, it's called methoxymethane because the parent chain only consists of a single carbon. That's why it's methane, single bonds, and carbohydrate, only carbon and hydrogens. But this becomes a substituent connected to CH3. That's why it's meth, but you have to make sure it's methoxy because it's a substituent group. Now, another way to name this group is dimethyl ether. The reason being is there is a methyl group on the right and there is a methyl also group on the left of oxygen. So we're not just going to say methyl ether because methyl is the same thing for both sides of this molecule. So we are going to be using just di. So it's dimethyl ether. And what's nice about ether is it's not just it's not just line formulas we could use, but also there are cycles. So this is an example of cyclic ether, and in this case it's ethylene oxide. So oxide, this is the way we refer to oxygen on ether molecule, but ethylene also refers to two carbons. Same way would be propylene. Propylene oxide when you have three carbons, something like that. So this kind of example would be propylene oxide. And so we understand that alkyl derivatives of water when it comes to ether. So if you take a look at this water molecule above, if you substitute hydrogens on both sides of this molecule with an alkyl or phenyl group, like a benzene ring, then you'll get an ether. Let's do a few practice problems. So first of all, we are going to write and provide the name for the two ethers with the formula C4H10 oxygen, just single oxygen. So there are a variety of different formulas you can write. Let's start with first example. So here we go. This molecule here has total of 4 carbons. It's 1, 2, 3, 4. And we put oxygen between carbon 1 and 2. And again, this is only one example. For the name, it's very simple because first of all, it's prop. So you know that this 1, 2, 3, this is your parent chain. Prop for 3 carbons. AN for single bonds. E is for hydrocarbon, meaning carbon and hydrogen only. And this right here, this becomes your substituent sitting on carbon 1. And this carbon 2, and this is carbon 3. So we refer to this molecule as methoxy. The reason being is it's only one carbon, which is methyl, but because it's OCH3, we call it methoxy. And also this methoxy is connected to carbon 1, that's why we refer to it as just 1-methoxypropane. Another way to name it is methyl propyl ether. The reason being is you got oxygen and you got methyl, or just one carbon on the right, and propyl, 3 carbons on the left. And you have to go by alphabetically. So you'll put methyl on the first position, propyl on the second position, and ether because that's exactly a functional group. Another example is this. So again, we have C4, 1, 2, 3, 4, and one oxygen. And also you can just count hydrogens. So 3, 3, 6, 7 on this one because one is invisible, and 3 more on this end right here. Because we understand that each carbon must have 4 bonds. Same went to previous structure. All these invisibles are hydrogens. And we understand to make it full view, it must be 4 bonds in a single carbon. So 3, 2, 5, 7, 10. So this makes H10. Same goes here. It's 3, 6, 7, 10. Now, as far as the name goes, and again, we see that this is the prop. So we got 1 methyl to the right of oxygen and 3 carbons to the left of oxygen. So this would be your parent chain right here. And we understand it's a prop because there are 3 carbons, AN, all single bonds, E, hydrocarbons, and on the second carbon, we get this, which is substituent. So again, it's a methoxy. The reason being is 1 carbon, methyl, and oxygen, methoxy. Okay, and it's all connected to the second carbon. So here is the name. For common name, you could also refer to it as, so to the right of oxygen, you get methyl. To the left of oxygen, we name this group isopropyl. So first of all, iso means equals, so that's why you have extension. So from single carbon in the center, you get 1 to the right, I mean 1 top, 1 left. So this is exactly iso, because from this extension you have equal number of carbons on both ends of these extensions. That's why altogether this is isopropyl, this is methyl, ether, and isopropyl and methyl are placed in alphabetical order. Next problem. We need to write bond-like structural formula for diethyl ether and for ethyl propyl ether and ethyl isopropyl ether. So here's the first molecule. So we got, first of all, we know this is ether right here because we have oxygen between 2 carbons, and it says diethyl. So there should be 2 ethyls to the left and right of oxygen. So this is your ethyl on the left, this is your ethyl on the right. So altogether it's diethyl ether. The next one is ethyl propyl ether. So, and again, this is the ether. Ethyl means 2 carbons on the left, so 1, 2, and propyl 3 carbons on the right. So altogether it's ethyl propyl ether. And finally, we get ethyl isopropyl ether. So here we got ethyl in the bottom, over here on the left. Isopropyl is over here, and for the same reasons we discussed before. And we got ether because that's what's functional group all about. The next problem. Now we are going to go other way. We are going to the name based on the structure. So for A, so the answer is methyl propyl ether. So here we go. It's methyl because 1 carbon on the left. Propyl is because there are 3 carbons on the right hand side, and ether just because there is oxygen between 2 carbons. So altogether it's methyl propyl ether. Alternatively, you could call it propane because there are 3 carbons, and on the left it's methoxy. So it would be 1 methoxy propane because 1 methoxy is a substituent. The second one is would be diisopropyl ether. The reason being is, so notice that first of all you got oxygen in the center. Oxygen goes between two carbons. On the left side you get isopropyl. On the right side you also get isopropyl. So we don't name isopropyl ether just because two isopropyls are the same, so that's why we refer to them as diisopropyl ether, which means just two diisopropyl groups. And finally, we get a chance to see phenyl or benzene ring, and the answer is methyl phenyl ether. So let me just tell you that the way to see this formula also is having CH3 group on this side, and sometimes you actually have pH. Sometimes it's C6H5OCH3, because this cyclic has 6 carbons, and each one has 1 hydrogen, except for this carbon, because this carbon has full stability, therefore bonds that we cannot draw anymore. But on this one, on that one, and on this one, and on this one, and also on that one, we actually can put 1 hydrogen, because each one of them has 3 bonds, and the 4th one is invisible. So in this case we got methyl, because of this single carbon. All of this cycle we refer to as phenyl group, and we have to write this in alphabetical order. That's why in the beginning you got methyl, followed by phenyl, followed by functional group ether. So together it's methyl phenyl ether. This concludes our tutorial. Please let me know if you have questions in the comments below. Like, comment, share, subscribe, and we'll see you in the next tutorial. Thanks for watching.